This statement says there exists a real number y such that this is negative. But how many real values of x is that statement true? So I want x minus xy plus y to be less than 0. And therefore, I decided to start with that and try and get y in terms of x, and therefore I could pick a y that would work. So if I factorize y out, I'll get y times 1 minus x, that's the second and the third terms, plus x less than 0. So y 1 minus x would be less than minus x. And I could then times through by minus 1, and it'll become y over x minus 1. I just flip the signs around there, is greater than x. Equivalently, you could add x onto both sides and minus this, you'd get the same thing. Okay, now I've got to be careful. This is an inequality, so I'm going to consider three different cases. Let's look at if x is greater than 1, because what I'm going to be doing is dividing through by this. So if x is greater than 1, I just require that y is greater than x over x minus 1. So, for example, if x was equal to 2, I could let y be, well, I just need it to be greater than 2 over 1, which is 2. I could let y equal 3. And then when I put it in, I would get 2 minus 6 plus 3. This would be negative. So as long as I pick a y that is greater than x over x minus 1, it's sorted. So the statement's going to be true for all these values. It's got to be careful with x equals 1. So back to here now, because if x is equal to 1, I can't actually divide through by x minus 1. So let's go back to the original statement. We would have 1 minus y plus y, and that would equal 1. So this is always positive, which means this is never true. No matter what, if x is 1, we can't pick any y that will make x minus xy plus y negative. And then let's take a look at x being less than 1. Then when we divide through by x minus 1, because that is negative, it's going to swap around, so y has to be less than x over x minus 1. But again, that's it then. As long as I find a y in that way, so let's do an example. What about x equals minus 2? Then as long as I do y is less than minus 2 over minus 3, which is 2/3, then I'm sorted. So e.g., I could let y equal 0. Then when I put that in up here, I would get, wait, what did I let x equal minus 2? It'd be minus 2, then just minus 2 actually. So in fact, I could always let y equal 0 in this case. If x is negative, just let y equal 0, and that will always be negative. So the statement is always true for x less than 1, which means it's always true for, well, it's true for all values of x except one of them, that x equals 1, and therefore our answer is going to be E.